panel where you can go ahead and submit questions. So feel free to click on that button. There should be a black bar, which is shown on the screen there. It says Q&A in one of the panel areas. Just click on that, and you can submit a question for me or for Jonathan or for anybody. If we have the opportunity and answer it, we will answer it during the session. If not, we will respond by email and answer any questions. If you think of something afterwards that you don't get to ask, go ahead and drop me an email, mike.yost@cesmi.org. And again, we will make sure to get an email back to you. If you're not familiar with the Zoom platform itself for webinars, you'll notice should see me in a little thumbnail, and very shortly you'll see Jonathan as well. If you do not like where the thumbnails are, just click on the thumbnails. It'll give you options for minimizing them or maximizing them or being able to move them around the screen, so you have them where you want them. And then lastly, this session is being recorded, so we will post it online as we do with all of the webcasts. And we encourage people to go online and watch them and contribute to the conversations that we're going to drive online as well. So with that, I'm going to ask Jonathan to turn on his microphone and unmute himself and join us. While he does that, just give you a little bit of background. I've had the pleasure of working with Jonathan for a long stretch, going back many years in many companies, and know that he is a true domain expert in our space, has a great great foundation, both on the industrial automation side, as well as on the enterprise software side. And so I think he brings a fantastic background to his leadership role within CESMII, and certainly look forward to hearing not only what he thinks today, but seeing how his vision and his experience feeds into CESMII in the long term as well. So Jonathan, thank you for being here.
Well, thanks, Mike. Thanks for having me.
You got it. Well, I'm going to start off, as we do every webcast, by throwing a simple question to you and turn the floor over to you of what would you say smart manufacturing looks like to you?
Yeah, so I think to answer this question, I want to rewind in history a bit and talk about my theory of alternate evolution. So on the next slide, I went as far back as VAX. And I kind of grew up in information technology development. That's what I went to school for, and that's kind of what I thought I was getting into when I started in the manufacturing industry. And we have sort of this base level expectation we call object-oriented programming. And the state of the art in software development has progressed beyond object-oriented programming, but it's the baseline, it's the minimum that we sort of expect to be present in a system. And it contains these structures and the fulfillment of expectations that most software developers depend on. The idea that data is represented as objects, we can interact with those objects inherit from a hierarchy that we can follow, so that even if we don't understand the current object we're in, we can kind of move up that hierarchy until we find something we know how to interact with. We can reflect on these objects at runtime and discover what they are and what they contain. And like I said, we've sort of moved beyond that in software development. We have other ideas we're exploring now, but this is the minimum bar. This is what we expect to be present. From what I've observed in 20 or so years, manufacturing technology had this alternate evolution that grew up out of electrical engineering rather than traditional software development, where our base level expectation in manufacturing are things like a tag database in a controller, or a copy of that tag database in a historian. The programming language, the verbiage we use comes from electrical diagrams. It's ladder logic. So there's this different set of expectations that create this impedance mismatch when you take someone out of college who studied software development and you ask them to build something new in a manufacturing environment. So the way that we solved this in the 90s and the early 2000s was a number of very smart people kind of simultaneously came up with the idea to layer an object model on top of the manufacturing environment. So we have the manufacturing technology, and then there's a number of kind of best-in-class industry implementations that allowed you to create objects out of that data and present those objects in a programmer's API so that we could write software against objects the way we expected to. What this created was a series of proprietary after-the-fact object models. The machine designer or the system builder was aware of what data was present. They expressed it in the tools that were available to them at the time, and then we had to re-express that in this structured object format using another layer of software. And what I'd argue is that that impedance mismatch and the solution we came up with to solve it, this layer of abstraction, has slowed innovation. It's created these sort of silos where I could solve it with one stack or I could solve it with another stack, but I couldn't move horizontally between those stacks. Code wasn't really portable. There was no minimum expectation, which is, I think, problem number one. There was lots of different minimum expectations. The only true common denominator, problem number two, is something that from a software development perspective is more primitive than what most software developers expect to find. So smart manufacturing, to me, to kind of restate the question, in 2020 looks like software development in 2002. We have to solve this problem in a industry standard way that everybody can agree this is the new baseline. Now innovation can start. We don't have to solve this other problem over and over again.
Excellent. Well, spoken like a VP of technology, so but very well grounded in the realities that we live in, right, and have lived in for some time. So can we break it down? Just so you started talking about innovation and value and things like that. So let's just take a step back away from the technology and the coding side of things. And what do you see as the value or the top few things that are the value drivers if we're able to make software development look, the object-oriented models and things like that? What does that look like to you or to the rest of the world if we're able to do what you're suggesting?
Well, you're right. I have a particular technology bias, and it sort of comes from my own disenfranchisement when I came fresh out of college into this new space, and none of what I learned was directly applicable. And so I've been trying for 20 years to find ways to solve that. But I think that frustration that I experienced 20 years ago hasn't really gone away. There are clever solutions to it. But the notion that we don't have a minimum platform, a minimum foundation on which we can build has hampered our innovation. If you look at, say, an iPhone or Android, so the two kind of prevailing platforms for mobile app development, the fact that there is that common foundation, there's two of them, but there's only two really. The other attempts have not succeeded. There's room basically for two. Those foundations allow people to rapidly innovate, to build apps, whether it's a single developer working in her basement, or it's a small team, or it's a big enterprise. You can build an app rapidly because you have a minimum set of expectations that are fulfilled by the platform. And all you have to do is build the new thing, the new idea on top of that. And you can get those things out quickly. You can get feedback from the marketplace in the form of customers or comments or reviews. And you can iterate and improve these ideas, or you can find out that the ideas don't work and you can move on. And you can do that quickly. And we can't in our space. Every kind of idea that you want to explore has to figure out, well, what's providing the data? How am I going to get it out? How am I going to cross the kind of Purdue layer boundaries to get it to my application so that I can test my idea? So technology is an enabler for other technology unless I have to repeatedly reinvent the plumbing. And that's naturally going to hamper innovation. It's going to slow things down.
So let's stick with that because your boss, the CTO, and I, Haresh Mokhani, and I have a pretty lively regular back and forth. I like to tease that there's as much work to do on the non-technology side of smart manufacturing as there is on the technology side. But I wouldn't be here if I didn't believe in what you're saying, that there is significant value to unleash innovation when these core data management, data infrastructure challenges go away. So your thoughts on unlocking innovation, and you started to touch on it, from a software development perspective, from an enterprise architecture perspective, from, a plant's perspective, a systems integrator, or a solution provider's perspective. Maybe just talk a little bit, because if you look at the projections of the value at stake for smart manufacturing, those folks are pointing to unlocking access to the data in the plants as feeding the value behind that. So talk a little bit from your perspective of what is possible if we're successful at doing this.
So I think you're saying technology is not an end unto itself, and I can agree with that. Haresh has a saying that I think is pithy, is worthwhile. We want to get the right information to the right people at the right time. Technology is an enabler for that, and I think it's inarguable that technology changes culture. I kind of referenced smartphones earlier, but within our lifetimes, we can observe how culture has changed by smartphones kind of proliferating. They are now kind of an expectation that we all have, that we have a large wealth of information at our fingertips. So if we can do that in manufacturing, and it probably doesn't look like an iPhone, it looks like other technologies, but if we can find the right technologies that allow people to get access to the information they need, then we can create a culture where the workforce is empowered to make better decisions, to test ideas, to explore things using the readily available information. We can enable this, we like to say democratization, but we can level the playing field so that you don't have to be an expert in every part of an operational technology and IT architecture in order to explore an idea. And that's why I think technology changes culture. It lets more people explore and learn and ideate and test theories, and that can only be good for manufacturing in the U.S.
Right, and for research, and for all the areas where you have technologies that are locked out today. We hold out hope for what machine learning and AI and big data and all those things can do in manufacturing. And if you have barriers in the way, obviously it impedes the ability for those to take hold and drive value as well. So,
to a fault, every machine learning or AI research project that I've seen in manufacturing starts with something like a CSV file. Somebody has exported a data set from a variety of systems, and they've given it to a smart research scientist or developer with the theory that machine learning might be able to create a prediction here, or we might be able to find a correlation here. And if that proves true, that's great, except you've got a whole nother set of problems. Now that I have this machine learning model to actually deploy it in manufacturing, I have to solve the rest of the problems about how the data gets streaming to that model and the results get back to manufacturing.
Right. Well, and when 3 out of 4 tasks are touched by humans and are outside of the automated systems, you introduce another problem of the holistic, value of solving those models. You mentioned here and have it on the bottom of your slide talking about crowdsourcing and creating de facto standards and stuff. Can you just elaborate on that a little bit? We have about 5 minutes left here. So take me down the path, take the viewers down the path of what you mean when you're talking about crowdsourcing expertise and sort of how we will go about doing that.
Okay, let me try to hit both a parent bullet and a sub bullet there. One of the technologies we think is going to enable this is something we call the Smart Manufacturing Profile. And the profile is a way for not the end customer, the integrator, to define the object model, but some expert closer to the source. So we can't rip and replace existing systems and say we're going to replace all controller code with object-oriented code. Nor can we say we're going to adopt a proprietary object model that we'll layer on top of it. We need to do better. We need to find some middle ground where the person who built the system can capture their knowledge of that system. And we call that a profile. And a profile is, at its heart, it's a class definition. It's an object-oriented programming concept. But just like a class definition in any modern programming language, a base class can always be extended. And that's kind of the first pitch for crowdsourcing, is one expert defines a base class that captures what they know, and they put that in the marketplace. And then another expert, maybe further down the line, extends that base class with the set of information they know. And the extension can happen infinitely. We think the marketplace is going to help decide what kinds of extensions are useful. But anybody could extend anybody else's class. You can capture your expertise and you can declare it and put it out there to be extended, or you can extend somebody else's expertise with what you know. So that's the first pass at crowdsourcing, is there are no monolithic specifications that a machine builder has to meet. They just have to capture what they know and make it available for other people to either use or extend. The other kind of crowdsourcing then would be the application development. So this is the cool visualization tool or the neat machine learning algorithm that somebody can develop on top of these models. And those people can take it as assumption from the smart manufacturing platform that the profile is a contract. The data will be provided to them and they don't have to worry about how to plumb 7 layers of the Purdue model to get to the data. They can assume this contract exists and will be delivered, and then they are free to innovate on top of that. And everybody is free to, just like in iOS or Android, try out an idea and see what the market is interested in.
And we know from experience, and I think others from experience, that how much work you're talking about replacing, how much work goes into that plumbing down through the Purdue model. And you know, I've heard estimates of 85% or more of the work is getting the data ready, conditioned, accessible just to be consumed, right? And so if you're able to go that path and leverage that extensibility and use this technology as a way to capture that domain expertise and abstract people from having to go through and do that plumbing, you're talking about significant value.
Yeah, we hope so. Yeah.
Yeah, excellent. Well, I truly appreciate your time here, and I warned you that this time was going to go very, very fast for us. To keep this to 20 minutes or less, so folks can hear from an expert like yourself, get a sense of where you're thinking, agree with it, disagree with it, what have you. And so with that, I would encourage everybody to again engage with us, ask questions, etc. But if we can, Jonathan, here, just I'm going to throw it back to you. If you give us a soundbite to take us out, one takeaway for everybody to say, what does smart manufacturing look like to Jonathan? What would you say to everybody?
I think if I could compress it to one statement, it would be something like, us as leaders in the industry need to rally around the idea of democratizing information access so that we can enable kind of a next generation of innovation to build on top of that.
Fantastic. I love that. I appreciate your perspective. And again, would just encourage everybody to engage with us, submit questions, email me if you have a point of view that you would like to share, or if you know somebody else you think should be on here, giving their point of view. I'd encourage you to please email me, suggest your topics, sign up to be a guest, sign up other people to be guests. We would love to have people on. With this being the holiday season, we will not be doing a second session in December, but we will be doing 2 sessions in January. January 8th, I'll be joined by Larry Megan, who's the Digital Innovation and Smart Manufacturing Leader for Praxair. And on January 22nd, Michelle Pastel, who's the Senior Manager for Manufacturing 4.0 at Corning, will be joining me as well. So encourage you to all keep an eye out for those. Have a happy holiday season, and hope to see you at another webcast soon. Thanks, Jonathan. Take care.